Trends in the periodic table. Describing trends found in the periodic table. There are many patterns in the chemical properties of elements that can be observed. Let's take a look. Atomic radius. The atomic radius is the measurement of the size of an atom in picometers. 1 picometer is 10 to the negative 12 meters. It's very difficult to determine. So one definition that is used is the atomic radius is 1/2 the distance between the nuclei of two atoms of the same element. The atomic radii will decrease from left to right across each period or row. So as you move along the periodic table from group 1 to group 17, the number of protons in the nucleus increase in increments of 1. Therefore, the nuclear charge will also increase. This will increase the strength of the attraction between the nucleus and the valence electrons and become stronger as protons are added. This nuclear attraction pulls the electrons closer to the nucleus, thus decreasing the size of the atom. It increases from top to bottom, the column. Each additional energy level places electrons at a greater distance from the nucleus. The inner energy levels are filled with electrons, which will shield the outer electrons from the pull of the nucleus. Outer electrons, then, are not as strongly attracted. This decrease of nuclear attraction felt by the outer electrons results in a larger radius. The next trend we will look at is the ionic radius. An ion is formed when an electron is removed from an atom. For example, if a valence electron is removed from a lithium atom, the lithium ion will have a smaller radius as there is one fewer electrons in the outer shell, making the charge positive. The removal of an electron from a neutral atom reduces the strength of the electron-electron repulsion. When an atom gains an electron to form a negative ion, its radius increases. In gaining an electron, repulsion among the electrons increases while the nuclear charge remains the same. If you look at this diagram, you will see the ionic radius of a positive ion is smaller than the atomic radius of the element. And as well, the ionic radius of a negative ion is larger than the atomic radius of the element. Now let's take a look at ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom or ion in the gaseous state. However, the amount of energy required is not constant depending on which electron is being removed. The first ionization energy is the amount of energy required to remove the most weakly held electron from a neutral atom. This electron is in the valence shell farthest from the nucleus, as it is most shielded from the attractive forces of the positive nuclear charge. So we have the element plus energy to produce the element as an ion with a positive charge plus the negative electron. The second ionization energy is the amount of energy required to remove a second electron from a gaseous positive ion. As you move from left to right across a period or row, there is an increase in ionization energy. As you move down a group in the periodic table, there is a decrease in the ionization energy. This diagram illustrates ionization energy. As you move from left to right, ionization energy increases. As you move down from top to bottom, ionization energy decreases. The next trend we want to look at is electron affinity. Electron affinity is the energy change that occurs when an electron is accepted by an atom in the gaseous state. So we have our atom joining with an electron to produce a negative charged ion. This energy change associated with this ionization process is referred to as electron affinity. And here is the trend. Electron affinity will increase as you move from left to right within a period, decrease as you move from top to bottom within a group. Electronegativity. Electronegativity is a number that describes the relative ability of an atom when bonded to attract electrons. Linus Pauling proposed a way of quantitatively describing the ability of an atom to attract electrons based on ionization energies, electron affinity, and other measures of reactivity. He gave fluorine a value of 4 and then assigned relative values in comparison to fluorine as their electronegativity values. Electronegativity values provide a means of predicting the nature of the force that holds a pair of atoms together. So let's take a look at the electronegativity trend. It generally increases from left to right, and it generally decreases as you go down a group. This trend is related to the atomic radii as you move from left to right. Electronegativity is also seen as being inversely related to the metallic properties of an element. Non-metallic elements have a strong tendency to gain electrons. As we move down a group, electronegativity decreases as an increase is seen in metallic properties. This diagram summarizes. As you move from left to right, electronegativity increases, and as you move from top to bottom, electronegativity decreases. Now, this diagram summarizes the direction for the trends that we've just referred to. You may want to make a sketch of this as you will need it for your assignment.